Hello and welcome to Mathematics with Simon. I'm Simon, and this bundle of fluff is Chewy. He looks very small, but actually, because that's a perspective effect, he's not really that small. He may get bigger later if he approaches, when he finds out about this roast chicken. Today, we're going to look at factorizing quadratic equations. So this is Algebra 3. Algebra 1 just looked at an introduction to algebra. Algebra 2 was simple equations or linear equations, and today it's quadratic equations. So quadratic equations look like this. X squared minus x minus 6 is 0. What is x? There are 5 ways of doing this. The first is just to guess, is just to put numbers in and see if they work. So just put in the number 2. 2 squared is 4, minus 2 is 2, minus 6 is minus 4, so that is not 0, so 2 doesn't work, but we could try other numbers and just try them one by one, see what works. The second way is to draw the graph. We can also factorize a quadratic, and we'll look at that today. And then finally, future videos will look at the quadratic formula and completion of the square. So here's a graph of y equals x squared minus x minus 6. And the solutions to the equation x squared minus x minus 6 equals 0 are defined by the points where this graph crosses the x-axis, because at that point y equals 0. So in this particular graph we can see it's crossing the axis at x equals minus 2 and x equals plus 3, so those must be the solutions. But there's another way into this, which is that we notice that x squared minus x minus 6 equals x minus 3 times x plus 2. Now this is important because when we see two things times together, like x minus 3 times x plus 2, if they equal 0, we know that one of them must be 0. Because if we think about it, if two things times together equals 0, one of them has to be 0. So that means either x minus 3 is 0, in which case x is 3, which is what we saw from the graph, or x plus 2 is 0, in which case x equals minus 2. So this factorization technique is really, really handy. But what's going on here? First, I just want to look at this. A plus B times C plus D equals A times C plus A times D plus B times C plus B times D. Now, why am I explaining this? It's going to explain why factorization works. And I'm going to draw a picture just to bring this to life. So here are 4 rectangles. One of them is A by C. The other one is A by D. The other one is B by C. And the other one is B by D. The point is, the area of the top left rectangle is A times C. The area of the top right rectangle is A times D. The area of the bottom left is B times C, and the bottom right is B times D. So altogether, the area of the whole thing is AC plus AD plus BC plus BD. But we can think of these rectangles in a different way. We can think of it as one big rectangle, which is A plus B in one direction, times C plus D in the other direction. So if I go back, this is one way of working out the area of the rectangle, A plus B times C plus D, and this is the other way, adding up all the little rectangles within. So that shows why these two things are equal. And that's important because that's what we use when we do factorization. So x minus 3 times x plus 2 equals x squared minus x minus 6, because it works like this. We go x times x is x squared. Then we go minus 3 times x is minus 3x. Then we go x times 2 is 2x. Then we go minus 3 times 2 is minus 6. So what we're doing is timesing this by this, this by this, this by this, this by this, all the 4 combinations. And we get x squared minus 3x plus 2x minus 6. Then we have these parts cancel out. So minus 3x plus 2x just leaves us with minus x. So we get x squared minus x minus 6, which is what we're aiming for. And what we're going to do in this video is show how to come up with these factorizations. Because once we've got the factorization, we can see how it's equal to the original quadratic. But we're going to explore how we come up with these factorizations. So let's look at another example. X squared minus 6x plus 8 equals 0. So This is how we factorise. So firstly, what we need is two numbers that times together to make plus 8. And also, they kind of have to add together to make minus 6. So, two numbers that times together to make 8 and add together to make minus 6, that has to be minus 2 and minus 4. And we'll just run through and show that this works. So what we're trying to do is find a factorisation that equals x squared minus 6x plus 8. So just to show it works, x times x is x squared, minus 2 times x is minus 2x, minus 4 times x is minus 4x, and then we've got minus 2 times minus 4, which is plus 8. So it equals x squared minus 6x plus 8. It works. And the way it worked was really, we just said, two numbers that times together to make 8, two numbers that add together to make minus 6, and they have to be minus 2 and minus 4. What I've done as well on the next slide is to draw the graph, but if we just think about this, so if x minus 2 times x minus 4 equals 0, that means one of these had to be 0, which meant either x is 2 or x is 4. Let's look at the graph. Here's the graph, whoops, parabola, and as we can see, it touches the axis at 2, it touches again at 4, and then it takes off again. So that shows that x equals 2 and x equals 4 are solutions. Let's look at another example. X squared plus 6x plus 9 equals 0. So what we really need here are two numbers that multiply to make 9 and add to make 6. Which two numbers multiply to make 9 and add to make 6? It's a slight trick question because it's not two numbers. It's actually x plus 3 and x plus 3. So it's 3 and 3. So the two numbers are 3 and 3 because they multiply to make 9 and they add to make 6. And if we just expand out the bracket, so x times x is x squared, then we've got 3 times x is 3x, then we've got x times 3, which is 3x, and then 3 times 3 is 9. So it comes together to be x squared plus 6x plus 9. That equals 0, which means that x plus 3 or x plus 3 will have to equal 0, which means that x equals minus 3. Here's the picture. We see the curve, it touches at minus 3, it lifts off again. Okay, let's do another. These should be getting more familiar now. X squared plus 6x plus 8 equals 0. So we need two numbers that multiply together to make 8 and add together to make 6. So those numbers are 2 and 4. So it's x plus 2 times x plus 4. So x times x is x squared. 2 times x is 2x. X times 4 is 4x. 2 times 4 is 8. Then we add 2x to 4x to get x squared plus 6x plus 8 equals 0. That means that either x plus 2 was 0 or x plus 4 is 0, which means that either x is minus 2 or x is minus 4. Here's the picture. The curve touches at minus 2, the curve touches at minus 4. Okay, here's another one. Now this one is a bit different. X squared minus 9 equals 0. So actually what we have here is no x's. So what we need are two numbers that multiply together to make minus 9 and add together to make 0. So those numbers must be plus 3 and minus 3. And it looks like this. X minus 3 times x plus 3. And then when we multiply out, we get x times x is x squared. 3 times x is plus 3x. Minus 3 times x is minus 3x. And then minus 3 times 3 gives us minus 9. So we end up with x squared plus 3x minus 3x just cancels out to 0 minus 9. X squared minus 9 equals 0. So if x squared minus 9 is 0, then x minus 3 times x plus 3 must equal 0, which means either x is 3 or x is minus 3. Here's the picture. It's beautiful. It's symmetric, this one, completely symmetric. So the curve comes down, touches at minus 3, which is one solution, comes under, and then goes back up and touches at 3. Of course, it hits the y-axis at minus 9. That's the y-intercept, because when x is 0, this curve is minus 9. Okay, here's another one. Now, what we've got here is we've got a number on the front and a number of x squareds. So the number of x squareds is not 1. So this changes things a bit. So now we still need two numbers that multiply to make 10, but when the number on the front is not 1, then the calculation works slightly differently. It works like this. So the factorization is 2x plus 5 times x plus 2. Here's how it's working. 2x times x is 2x squared, so that's fine. So we need a number of x's in these brackets that mean when we multiply these together we get 2x squared. Then we've got 2x times 2, which gives us 4x. Then we've got 5 times x that gives us 5x, and then 5 times 2 gives us 10. So 2x squared plus 4x plus 5x, which just goes to 9x, and then on the end we've got the 10. So the clever bit here really is we did 2x times 2 was 4x, x times 5 is 5x, and then 4x plus 5x gave us 9x. So if 2x squared plus 9x plus 10 equals 0, then we know that 2x plus 5 times x plus 2 equals 0. So either this is 0 on the right, in which case x is minus 2, or this is 0, in which case if 2x plus 5 is 0, then x will have to be minus 2.5 to make this work. Draw the picture, we can see them, minus 2 and minus 2.5. Okay, in this case, instead of a 1 on the front of the x squareds, I've put a minus 1. So it's minus x squared plus 3x plus 10 equals 0. Factorization, we need two numbers that times together to make 10, and then we've got to make this bit work. So what we get is this, minus x plus 5 and x plus 2. Let's look at this. So minus x times x is minus x squared. 5 times x gives us 5x. Minus x times 2 gives us minus 2x. And then we get 5 times 2 gives us 10. Phew, and then to simplify we go plus 5x minus 2x is plus 3x. So we end up with minus x squared plus 3x plus 10 equals 0, which is what we were looking for. And if this lot equals 0, that means either minus x plus 5 is 0 or x plus 2 is 0. In the former case, x is 5. In the latter case, x equals minus 2. Let's look at the picture. X is minus 2 and x is 5. Also, the parabola is upside down because the number of x squareds is negative. And when that happens, it turns the parabola upside down. So we're going to finish with Gary's closing question. Gary is a regular viewer. Give me lots of great feedback on the channel. So I'm going to leave you with a closing question in his honour, which is x squared minus 4x plus 3 equals 0. What is x? Please do it any way you want to. I'd love to hear from you in the comments how you approached it, and we'll do more in the future. So hopefully the next video is quadratic formula, which is a different way of solving quadratics, and completion of the square. If you have enjoyed this, please hit the like button. If you want to see more in the future, then please hit subscribe and the notification bell. I very much hope you enjoy your mathematics. All that remains is to give Chewy a piece of roast chicken. Now, he's ever so comfortable, but this chicken is absolutely gorgeous. Look at this. Chewy, you want some chicken? Oh, he wants it. He definitely wants it. Come on, mister. Ugh! It's a dog. It's a piece of chicken. It's a beautiful thing. Look after yourselves. I hope lockdown's treating you well, and we'll all both see you soon.